cool. So yeah, an introduction. Yeah, web apps are cool, but have you ever made your own game? Games are pretty neat because they're one of the best beginner ways to sort of put all of that coding knowledge into one cohesive project, right? And I mean, games are fun. Who doesn't like games? Am I right, gamers? So anyway, I'll admit a bunch of us here have probably made sort of games for their first few hackathons, because I know I have. Anyway, in case you've been living on a rock and you don't know what a video game is, I provided some great examples of what video games are. So for example, you have Among Us, which interestingly enough is actually developed by a team of 2 to 3. So if you're thinking about making Among Us 2 in the next SD hackathon, well, just keep that in mind. We also have games like Valorant or Super Mario. Wait, I didn't even start recording yet. All right, let me start recording this before I continue any further. Okay, I can't record because I don't have permission from the host to record. Oh, it is recording? All right, cool. Sorry about that. Anyway, there are more examples of video games like Super Mario Bros. 2, Game of the Year every year, and then we also have Knack and Bug Snacks, right? Great games. So now that we've gone through a little introduction, I'll outline what the workshop will look like for the next hour. So first, I'll be here with the slides to introduce you guys and set up the tools that we'll be using today. So in this case, we'll be using Phaser and Tile. So that'll take about 20 minutes. Next, I'll let Jared take over, and he will demonstrate our little 2D platformer game project, and he'll also teach you how to code aspects of the game, for example, the player controls and the player collisions. After that, you guys will be able to make your own custom levels as well. So after we finish the demo, you guys can submit your own custom levels and we'll showcase some of them, or you can also access it through a Google Drive folder that we'll be providing, and we'll also open up the floor to questions and answers. So this workshop is intended for beginners, but a little bit of coding experience is required, just a little bit, and preferably in JavaScript. So if you were at that web dev meeting, and you learned that JavaScript, you're pretty much set for this workshop. So now let's introduce the tools that we'll be using today. So what is Phaser? Whoops. Phaser actually stands for Pretty Hype and Saucy Engine, right? Well, it doesn't actually, but it should, because it's a free and open source 2D game framework for making HTML games. So pretty much our game project today will be a browser game, a game that you can pretty much play on the browser, right? So games created in Phaser are programmed in JavaScript. So as mentioned before, and you might be wondering why we're using something lesser known like Phaser as opposed to something prominent like, say, for example, Unity. Well, the thing about Unity and other big game engines like that is that it takes a hassle to just get everything set up and installed correctly. So the thing about Phaser is that you actually don't need anything to install in order to use it. It might sound like an exaggeration, but it's pretty much just one line of code inside of your HTML file. So wow, that's pretty cool. Next, I'm here to introduce Tile. So Tile actually stands for Tiling is Legendary and Extremely Dope. Well, it doesn't actually, but it should, because it's a free and open source 2D level editor, and we'll be using that to create our custom levels in the game. So Jared will go into detail on how to use it later, but as for now, you can see on the UI, it's pretty intuitive. You've got your tile sets here, and you can pretty much draw out your level over here on this grid, and you can divide your level into different layers. For example, the foreground, background, and you can also divide it into stuff, categories like collectibles, like coins, or stage hazards, like spikes and lava. All right, so you can download it from the website here. It'll also be on the GitHub page that we'll provide later on. So if you guys want to get a head start on the demo, and if you guys would like to follow along, just set that up real quick. And other than that, that's pretty much all the tools we will be using for today. So why don't we get started on setting up our project? So to get started, you want to get our starter code over here. Oops, I'll send a link in the chat, unless someone has already done it already. Okay, so Jared's already got my back, and he's already sent in the code. Awesome. So you can just pull from the repository itself, or you can download it as a zip file, however way you like it. Once you open it, your folder directory for this project should look a little bit something like this. Not exactly like this, but similar. So you'll have the workshop file folder, and then you'll have a folder for all the assets. This will be all the sprites we'll be using today, and then a folder for the maps that we'll be creating, and then two other files, the game.js file and the index.html file. And I'll go a little bit more detail into those later. One other thing to run this project is we need to be able to run a local web server to run and test our game. So this is mostly because about security stuff, but the good thing is that it's pretty easy to set up a web server. And instructions will also be on our GitHub page, but for now, if you have Python, you can just run python 3-n HTTP server in your workspace folder via the terminal, or if you're developing using VS Code, you can just install the live server extension, and there will be a little button on the bottom of your IDE that you can click. I'll start and stop the server for you. So let's go a little bit into a little bit more detail about these two files that I mentioned earlier. So the first one is the index.html file, right? And that basically contains two parts to it, the head and the body. So in the head, we'll have the title of our game as seen over here, and we'll also have a style. And this basically styles the game container div. In that case, you can set the resolution, like how big your game will appear in the browser through these options over here. And the second part is the body, right? So you first have the div for the game container, so your game will be just ran in here. Next, you have two scripts, and the first script is just the phaser framework. So like I mentioned before, it's kind of crazy how you only really need just this one line of code to get phaser framework to work with your game. And the next script is going to be the game.js script, right? And this contains all of your game code. So moving on to the game.js, right? So what's inside of it? There's four parts to it. And the first part is the game instance and config, right? So this is pretty much your instance of the game, I guess. And the config is just a bunch of settings that you can play around with that deals with how the game is rendered on the browser and also sets up the default physics engine type. So for us today, we'll be making a 2D platformer with a twist, and we'll be using that kind of physics engine. But let's say you want to make a game that's a top-down shooter instead, that relies on different physics, and so you can change that up in the config. So the next three functions are pretty much part of our game. We have the preload, create, and update function. And for those of you more familiar with, say, Unity, think of it as the await, start, and update function. So just briefly, the preload function basically runs once right before your game starts. And usually what you do in the preload function is to upload all of the assets you're going to use before starting the game. Now, the create function is run at the start of every level, essentially, right? So anything you want to do to initialize the environment and the objects in the current level, you would put that code in the create function. Now, finally, you have the update function, and it pretty much runs repeatedly while the game is active. For example, once every frame or something like that, right? So in that case, usually you want to put code that handles the input as well as the player physics, as we want to consistently update this over our game, right? So that's just a brief overview of what the code will look like. Jared will go to that and into more detail on that. And finally, again, be sure to install Tile. It's on the website over here. It's also in the GitHub repository as part of the instructions. And one thing I didn't cover is, so you might be wondering how the levels we make in Tiled gets used in our game script. Well, the thing about Tiled is, and Jared will demonstrate this later, but you can just export your level as a JSON file, and then your game can pretty much parse that JSON file and create the game in the game. So yeah, it's all come together. So again, if you haven't installed Tiled, be sure to do so if you want to follow along. It's free, and you can always install it later. Other than that, we'll move on to the demo section now. So I'll let Jared take it away.
All right. Hey, y'all. So let me just share my screen really quick. So this is the sample of the game that we're going to be making today. So you'll kind of see, and the thing is blocking my screen. Okay. So what we basically have right here is kind of like a little play on the game Geometry Dash. You can collect different coins. You can miss them. There's some traps. You've got spikes right there. You've got lava, which I cannot get to because I'm bad. There it is. There's the lava. And then the rest of the things is if you run into a wall, you kind of die in the game reset. So we're going to talk about exactly how we're going to get this all running and working. And to start with that, let's talk about Tiled, because that is the thing that we've been asking you to install. So let's take a look at that first and foremost before we start downloading the code. So let's take a look at Tiled. If you haven't installed it already, I've put a link to it in the chat. Also, if you head to our starter code repository, you will find a link to the Tiled engine right here. So if you hit that, download now, and you say just no thanks, take me to the downloads, you can download the version that's appropriate for your computer first and foremost. Once you have this running, and once you have the starter code, then we can kind of go into that. Now, to get the starter code, I'll just do it very quickly using Git if you're familiar with it. Otherwise, you can just hit the download zip to get the starter code. But I'm going to just use GitHub to do it. So let's just hop on into here and let's download our starter code. Head into the directory. And we talked about how to get this running. If you're using Python, Python 3, you can say python -m http.server, and then a number. I'm going to use 8,000. And so this will start a server for this. And so what you start with, so this is the end product, but what you start with is this. You have the map, no collisions. It just kind of drops to the floor, right? So let's take a look at first the level. And now that we have the starter code, we can actually do that. So if we open up the Tiled editor, so this is Tiled, and we say File, Open, and we go there to the Workshop Game Dev Starter. Brian talked about the index.html, the game.js, and the assets, but the other folder that we have is maps. And so in maps, we have map example, which is the one that we are currently playing on right here. So you'll see this is the same level. We have another map, which is an example map for later, which is a little more complex level. And then we have map template. And map template is a completely blank map. And the reason why this is important is because when you're working with Tiled, you have what are called layers. So let's hop onto the map example to kind of demonstrate how this all works. For map 1, a little bit more complicated. If we hide all of these layers, you can see individually what each layer is. So if we take a look at platforms, this is just all of the blocks that you can jump on. If we look at spikes, this is all of the spikes, the little objects that you would run into that would kill you. You have the lava, which the lava layer is just the lava, as you'd expect. Coins are the different coins in the level. And then the goals for us are these things, which are little chains. And if you run into these chains, then it gives you the, you've won the game screen that you can kind of see on my camera when it finishes. So here, these are the different layers. And when you're working with them, you have to make sure that you put things on the right layer. Reason being is if you put like a coin on the platforms layer, then it becomes a platform that you can jump on instead of a collectible. Or if you put lava in the coins layer, then you're instead going to be collecting lava instead of coins to get points. And none of that makes sense. So you just have to be a little mindful when you're making these different ones. So in the template that we gave you guys in the map template, this one is completely blank, but it does give you all of the layers to work with. So you have the platforms, spikes, lava, etc. So to start off by putting platforms down, we can just click on the platform layer and we would select this tool. This is the it's the stamp brush tool, and this will place down a tile. So we can select from these four. Technically, we could use these as well, but if you do, again, it will turn it into a platform, and that's not what you want. But you can use any of these different platforms. They're just for aesthetic purposes only. The different variants are really just to add a little bit more variety. So you can kind of just see how this will all work. You just put some stuff here. So maybe make a jump here, smaller jump here. And then you can erase it with the erase tool. So let's say you wanted to add lava right here, right? So we can erase that instead using this erase tool. And then let's add some of these ambient objects, right? So these are object layers. So for objects, you have to be a little more precise with these. So if you take a look, and we kind of just zoom in here, if you select the spike, so we're on the spiked layer, and you select this tool, kind of looks like a photograph. If you click that, that's for inserting a tile. But you'll see we can actually insert tiles that are not aligned with these grid lines, right? So we don't want to put objects down that aren't aligned with these grids because it's just not good to do so. So to align it with the grid, you will hold the control key. I am assuming it's command on Mac, but on Windows it's control. And when you hold down the control key, now it makes sure that it's snapped to the grids. So let's add 3 spikes like that or so. Then let's head over to the lava layer. Let's select the lava tile, and again, control to snap it to the layers, to snap it to the grid. And then let's just add some coins, right? Oh, and by the way, to zoom in and out, it's control minus to zoom in, to zoom out, control plus to zoom in. So that's just something for going in and out. Let's add some coins that we can get. Let's add one that you can get by jumping here. Ooh, not aligned, right? Control, there you go. Let's add a coin that you can get here, maybe. Let's add a coin that you can get there. And let's just add a really basic coin. Why not here? Sure, why not? And then you have your goals, and I'm doing this on the lava layer. What am I doing? Oh my goodness. Coins layer. Just place those down again. Act like I didn't make that mistake that I said not to do. Just put that on the coins layer now. And then goals layer, we're going to select the goals. And these can actually be placed anywhere. So if you wanted to say use it as a hazard instead of an actual goal, like, oh, you'll end the game if you accidentally step on that, then you can just place it anywhere. Most people would probably put them at the end of the level, but you can put them really anywhere. So now we have our goals down. And the way that the program will also work is it will find the highest platform on this at 0 on where to place you. So if you say put a platform here, it will put you here instead, right? So let's just remove that though. So then all you need to do is save it. I'm just going to save this as map2.tmx. And then you want to export it to a JSON file. And this is so that it can be read in by the tiled engine, or by the phaser engine. So now we're just going to save it as map2.json. So if we hop on over here to our level editor, you'll see it's still the default level. We now have to start messing with the code in order for it to load in the level that we've just created. So let's take a look at the code. So I'm going to open up to the starter code directory that we have, temp workshop, here we go. And while we're in here, we can go into our maps. You'll see now we have map2.tmx, our new map that we just created. And in here, we now have game.js. Now you'll see some of the functions that Ryan talked about earlier. You've got the preload function, the create function, and then you've got yourself the update function. And so the places that we're going to want to edit the code, there are 3 places. First is going to be here in the preload when we want to select whatever map we're going to be using, right? Right now it's map example. Let's say we want to use our new map, right? Let's say map2.json, right? And if we do a refresh here, what is happening? Did this export correctly? File, export as. Oh, map2.json is not here. Project refresh folders. I don't think I saved it to the right directory. Hold on. Export, we want to save this to, my bad. There you go. Temp workshop maps. There you go. map2.json. Yikes. So now if we refresh it, we'll see the map that we had just created, right? So, but again, we have none of the collisions, still not touching anything. So we have to start working on that as well. So let's take a look at the other places that we're going to want to modify within the code. This is not the right one. Within the code. So in here, we've got our other places. So if you search for the word to do, you'll find all the places where we're going to be making changes. So here, we've already changed it to a map of our choice. Here, we're going to be doing all of the collision code. And then down here, we're going to be doing all of the moving, the physics of the engine, right? And the controls. So let's start off by adding some very basic collisions, right? Now, the collision function is as follows. So let's kind of zoom in here so you can really see what this function is. It's this .physics.add.collider, and then you're going to put in the first part the thing that you want, the object that's going to be moving, the one that you want to collide with other things. So in this case, that's the player. And our player is defined up here as this .player, so you just use this .player. And let's start with this first one right here, adding collisions with platforms. So that's just this .platforms. There are additional arguments that this function can take, and that's going to be the function. And then here, don't worry about what this one is, but these last two should be null in this if you're going to be using this. But for now, with platforms, we just want it to collide. We don't want it to call a function that like hits a spike or hits lava. It's just there to be objects to run into. So we just want the basic collider. So when we do this and we rerun it, you'll now see the frog is just stopped on top of this tile because it has now collided with it. So now it's just going to kind of stop when it hits it. So we can kind of see already how this is going to play out. We're going to now add all of the colliders for all of these other ones, right? So for hits for spikes and for lava, we would use the other version of the collider. So I'll do this for the spikes, and then once you kind of see what I did, try to do it for the lava, all right? So we're going to say this.physics.add_collider, this.player, and instead of platforms now, we have our spikes, which are defined here, right? So let's use spikes instead, and we want to use this function hitSpike, and hitSpike is up here, and all it does is when you run into a spike, reset the game. You know, it's a very simple kind of handler for when they collide. So if we just say hit spike, that's our handler for hitting a spike. And then you can add after this the null and the this. And what these arguments are, you're passing in a reference to the current game object. That's not too important. And this one, I'm not really going to go too much into depth because You don't need to know about this argument quite yet. Just know that after you've put in the handler, you want to put null and this. And then I'll show you specifically for coins, because if you look, you've got goals and you've got coins, and both of these use the overlap function. So overlap is a special type of collider. Instead of having it so that when you run into it, it also initiates the physics, right? If you run into spikes, you should also stop when you hit the spikes, right? Now for us, you won't notice it because it will reset the game really quickly, but that's the type of collider we want to use for solid objects, right? But for coins, on the other hand, coins, you kind of want to run into it, and instead of stopping when you hit it, you want to just continue going afterwards. And same thing with goals, right? Goals are not solid objects. They are things that you want to tag and then keep going if it didn't already win the game, right? So we're going to use this dot overlap, this dot physics dot add, very similar to the collider, but instead of using collider, we're just going to use this one called overlap. And then everything else in the parameters are pretty much identical. So let's take this and kind of move it under the comment so it makes a little more sense. So we can pretty much copy the inside of this. And it says we want to call collect coin, and collect coin is defined up here. All it does is it increments the score and then displays it on the screen. And then it also just gets rid of the coin on the screen as well, just to indicate that you've picked it up, right? So let's scroll back down here and let's actually finish up this overlap code. So let's add in, let's change it from spikes to coins. And instead of hitting a spike, we want to collect a coin. And then the rest of it, again, null and this. So with this in here, we won't see any changes quite yet because the player is not moving. But if we just have him move to the right and grab that coin, then we can kind of get started with that, right? So let's, now that we have some of the basic colliders in there that we can't really see in action yet, let's get it moving. So if we take a look down here at the other instance of do, in the update loop, the update thing runs every single frame, so it just continuously updates. And so here is where you're going to want to add some of the code for the physics. So let's start with this one right here, setting the player's velocity to 250 in the positive x direction. In case you need to know the axes for games, 0, 0 is in the top left, and then the bottom right-hand corner is going to be, in this case, 800, 600, because it's 800 wide, 600 tall, and that's going to be the bottom right-hand corner. So for us, the positive x direction is moving this way towards the to the right. Negative x is to the left. Negative y is up, and positive y is down, because this is 0, 0, and this is 800, 600, right? So we're going to set the player's velocity to 250 in the plus x direction. Now we have a reference already up here on how we can do some of the things that we need to do. So you'll see this function right here, this.player.setVelocityX. So what this entire piece of code here is, once you've won the game, it kind of just freezes the character in place. It stops its movement on the y velocity, takes away its velocity, its gravity, so takes away its movement on to the left. But now we want to add movement. So instead of saying this.player.setVelocity0, we can say this.player.setVelocity 250. And you can change these values if you want. It doesn't have to be 250, doesn't have to be whatever we set. You can even modify the gravity down here, and you can play around with the physics once we kind of have a more complete version of this game, right? So let's just add this one line in, and let's see what change it makes. So if we just refresh this, now he just moved to the right, and he collected that coin. You'll see our coins incremented, and now we have coins 1 through 4. But that's pretty much all it does right now. We kind of want to add the ability to jump. We also want it to not run into a wall and completely stop the game, right? So we want it to, when it hits the wall, reset the game. And we also want to add these the rest of these colliders up here, which I've challenged you guys to kind of use what we have here to figure out what we're going to do next. So try to do the reach goal and the hit spike while we kind of go over some of these other things. So the next thing that we're going to want to probably look at is jumping, right? Because that's a pretty essential thing in this game. And the jumping is going to be pretty simple. We want it to be able to hop when you press this, when you press the up arrow on your keyboard. So what we have up here is if this dot cursors dot space dot is down. So this is the thing at the end of the game that says, hey, you've reached the end of the level. Why don't you reset the game? Why don't you try? Why don't you press space to restart? So if we want it to be the up arrow, it's quite simple. We just change this dot cursors dot space to this dot cursors dot up. And this will check, is the up arrow on your keyboard pressed down? So that's all this does. And if so, then let's set the velocity to be 470 in the negative y direction. So let's do that. Let's do negative 470 in the negative y direction. And this is a very naive approach, and you'll see exactly why when we take a look at what it does, right? So I'm going to start moving, and we can jump. Yeah, that's good. That's as expected. Oh, and you can see the spike collision code that we implemented earlier is indeed working. Our goal collision is not yet working, but this at least is. But here's the problem. Now you've made Flappy Bird instead of making a platformer. So we don't want that. So we need to add a check to see that it's actually touching the ground before we do anything else. So let's try that. And what we're going to need to do, there's no reference for this yet, so I will add in, I'll show a little print statement to show you kind of what's going on. If we say this dot player dot body dot block, okay, this is an object, and I'll show you what this object is. If we refresh this and we take a look at our console real quick, if you take a look at our console here, you'll see it's printing out a lot of this information about random things. So if you kind of take a look here and look into this object, hopefully you can see that. We'll zoom in a little bit. So here we have down is true, left is false, none is false, right is true, up is false. So down basically means you're touching the ground, right? So you'll see Froggy, he's touching the ground. Right is true, means that it's touching the wall. So on the right side, it's colliding. But on the left, it's not colliding. Makes sense. And above it is not colliding. That also makes sense, right? So because there's nothing above it, there's nothing to the left. So all we need to do now is just kind of use these values in order to limit when we can actually jump. And when do we want to jump? When we're on the ground. You know, we don't want it to jump any other time than when we're on the ground. So we're going to use this one, right, the down, to check and see that we are actually touching the ground before we allow the user to jump, right? So we have our check here that when the up arrow is pressed, jump. Well, we also wanted to check this dot player dot body dot blocked, and instead of and then we wanted to check, is it touching the ground? If it's touching the ground and the up arrow is there, then we allow it to jump. So let's take away this print statement and let's just see what this does. Now, if I hold the up arrow, you'll see it only allows me to jump exactly when I am actually hitting the up arrow on the keyboard, right? So perfect. Now we've done some really basic collisions with walls, or sorry, with the ground. We've detected when it's touching the ground. We've managed to get the coins working, and if you've gotten the lava and the spikes working on your own, congratulations. Now we want something that when it runs into the right wall, reset the game, right? We want it to actually have a little bit of some playability value and not just, hey, let's stop when we hit a wall, because that just breaks the game loop, right? So let's do this thing right here. Check if the player runs into the wall, then reset the game. So if we put our if statement here, obviously the inside of this if statement should be reset game, right? Do we have any ideas of what we can do to check that it's running into the right wall? We kind of touched on this earlier. It has to do with what we did here. I'll give it like maybe 10, 20 seconds in the chat if you guys have an idea of what this check should be of when we run into the right wall. for the sake of time, let's just put in the if statement already. So we were using player.blocked down, right, to check that it's on the ground. So if we're looking for running into a wall, we want to check, is it blocked on its right side? So if we take a look now at the game, now whenever it runs into a wall, it resets and the game starts over. And it restarts the coin counter, it restarts like all of those important little things. And now you actually have a little more of a game at work because you've got yourself all of the different collisions with the walls. And now the only thing is the lava and the spikes, or sorry, the lava and the goals to make sure that you're actually on track to finish the game, right? So let's take a look back. Let's loop back around to what we were doing earlier with this, and I'll give you the answer for how we add the collisions for this. And this is one of the things with Phaser. It's very, very simple to do pretty much anything in it. So instead of spikes, lava. Instead of hitting a spike, lava. And then we add the overlap, and this time we add it for the goal. So let's change that to goal. And instead of collect coin, we want to reach the goal. So when we have this, we now have our fully functional version of, oh, wait, reach goal, this dot goal. Unless I put this on the wrong layer, which I may have. No, that's the correct layer. It is just not interpreting the goal correctly. I may have made a mistake in the starter code. Let me check. Goals, plural. Thank you. That is correct. When we do that, okay, there you go. If you run into the wall, into the goal, it will finish the game. So let's try winning our level. Now you've collected all the coins, you've won the game. Now you can actually focus on things like creating the different levels and creating more complicated gameplay stuff. So, you know, if we change it to map 1, which is the one that I prepared before the class, you'll have something that looks a little more exciting. You've got lava down here. You can go grab this coin. You've got multiple different coins that you can grab. And you can just now play around with the different coins and those different things. And you can also play around with the physics, right? Let's say you want to make the game a little bit more fast-paced. You can change this and be like 400 on the velocity. And now you've got this really way too fast game where now it's pretty much impossible to make some of these jumps. But, you know, feel free to do whatever you want with this. You can change your jump height, right? Say you want to jump much higher. Let's change this and look at that. The ceiling is going to be wherever the map ceiling was, and there's no real indication of where that is. But if you know that your map was like 20 tall, then the ceiling is right here. One thing that I did kind of forget to mention in tiled, speaking of which, the world borders. If you want to make the map longer, because obviously this is a very quick level that you can complete relatively quickly. If you want to make this level bigger, all you need to do in tiled is just say map, resize map, and then you can make this as arbitrarily large as you want. You know, if you want this to be 1,000 tiles long, then you have a lot of space to work with, and it's going to be a really long level to complete. But, you know, you have free reign to kind of change the map size, make it as tall as you want, make it as short as you want. If you want it to be one block, you can do that. There's really a lot of things. One last thing here, if you look in the gravity, you can also change this. The higher this value, the higher the gravity. So if you change this to something like 100, and let's just reduce the jump height now because we don't need that much jump height, you'll see we now have like moon physics. So that's a pretty interesting one that you can play around with. Just play around with these different gravity and velocity values until you have something that you can kind of work with and play around with. And last but not least, after all of these physics are done, you might want to have animations, right? So our frog right now isn't moving. So, kind of not really doing much, just kind of sitting there. So you'll see in our assets that we actually have 3 frames here. So in the game.js, we've actually already taken the liberty of creating the animation in the phaser engine. It's as simple as just putting moving, what the frame rate should be, when it should repeat, and then your starting frame and your end frame, with 0 being the first frame and the end frame being the second frame being the third frame. So you'll see 0, 1, 2. So those are your frames for this animation. So all you need to do now is add in one very simple line of code right here, the last thing that we left out here on the update function, add player animation moving. And this is this.player.anims.play, the name of the animation, which is moving. And for animations that don't have any frames, you can just do true. You can just do this, and this will just be changing to a static sprite. But if you want it to be a one that actually is active and like moves and is animated, add true to this. And when you add true, it will do this. So now you've got your animated frog moving along here, just chugging along. You can now play the game, work with the levels, and I will throw it back to Ryan now, and he will conclude off the workshop, and then we'll just mess around with the levels afterwards, and you can upload your own, and we'll just play them.
All right. So yeah, that's pretty much it for the game dev workshop. Thanks again to everyone who came by here to attend the workshop. Here, let me get my screen real quick. Okay. So yeah, we finished the demo. Once again, apply to SB Hacks 7 now on our website because applications are live. Be there or be square. And for everyone who's made it till the end of our workshop, we'll send you guys a check-in and raffle link. So if you just fill out the form with just your name and all that jazz, you get a chance to, you get put into a raffle with a chance to win a JBL Flip 5. So that's pretty neat. Where is the chat? Oh yeah, and then also I'll be sending a link to just a Google Drive of all your level submissions. So when you're submitting your form, you have the option to submit just the JSON file of your level, and you can also see what levels other people have created through this Drive link. So here are the 2 links. And finally, last but not least, if you're interested in learning more about making games, we do indeed have a game dev club on campus, and I'm totally not affiliated with them in any way at all. Other than that, we'll open up the floor. Here's our social media info. We'll open up the floor to any questions, any feedback, and we'll just fool around with the levels. Once again, thank you all for coming.